Far beyond the last planet, a fragile machine still speaks.
Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish.
Voyager 1, built with the technology of another era, continues its slow journey into the unknown.
By 2025, we will have to turn off the last instrument, and that will be the end of the science mission, and the two spacecraft will then forever orbit the center of our galaxy silently.
Its signal is faint, stretched thin across more than 14 billion miles, yet it reaches us still.
We still communicate with the Voyagers. They send us signals every day.
It carries not only data, but also a memory of who we were when we first dared to dream of the stars. Now, after decades of silence and steady whispers, something strange has begun to echo in its voice.
So this all began way back in November when, as you say, the craft just wasn't sending back anything that we could unravel back on Earth. It was all nonsense.
A signal no one expected, raising a question without an answer. A journey that never ended. In the summer of 1977, the world was different. Computers filled entire rooms. Phones still had wires. Music was stored on vinyl records and cassette tapes. Yet, at Cape Canaveral, a spacecraft was being prepared that would carry the dreams of humanity farther than anyone imagined. It was called Voyager 1. The spacecraft was not large, barely the size of a small car, with long antennae and instruments reaching outward like arms. Its design was simple compared to today's machines. It had a memory smaller than a pocket calculator, and its transmission speed would seem painfully slow by modern standards. Still, what mattered was not its power, but its purpose. Voyager 1 was built to travel farther than any other probe and to look closely at worlds we had only seen as dots of light.
Response is normal.
When it launched on September 5, 1977, it carried with it the hopes of a generation. Scientists had mapped a rare alignment of planets that happens only once every 176 years. With careful planning, Voyager could swing from one giant planet to the next, using their gravity like a slingshot to propel itself outward. The mission's first goal was clear: explore Jupiter and Saturn. If it survived that long, the probe might even send back glimpses of their moons. For a world that had never seen these planets up close, the images Voyager returned were breathtaking. Jupiter's surface revealed storms larger than Earth, swirling in endless patterns of color and lightning. Its moon, Io, showed volcanoes erupting into space, a discovery that no one had expected. Europa, with its icy surface, hinted at oceans hidden below. Then came Saturn, with its delicate rings, thousands of icy fragments circling in silent harmony. Voyager's camera turned those distant mysteries into real places. Humanity saw them as landscapes, not just specks in the sky. The mission's official objectives ended after these encounters. The spacecraft had done its job. It had traveled where no probe had gone before and sent back discoveries that rewrote our understanding of the solar system. Yet, Voyager 1 did not stop. The slingshot paths around Jupiter and Saturn had given it enough speed to break free from the sun's pull entirely. Instead of looping back like the planets, it was on a one-way path outward, into the deep unknown. This was when the mission began to transform. What had started as a planetary survey became something greater. Voyager 1 became a traveler beyond maps. With each passing year, it moved farther from Earth, and yet it continued to send back signals, tiny packets of data carried across billions of miles. Its mission team changed over time. Young scientists who had watched its launch grew old. Some retired, some passed away.
I would take a poll, but it was not literally a vote in the sense, because I didn't feel that the science should be decided by vote. It really had...
New engineers, who had not even been born when the probe left Earth, now managed its care. The spacecraft itself never slowed. It simply moved forward, away from everything familiar. Behind it, the sun and planets grew smaller. Ahead lay only the dark. Yet inside its systems, the instruments kept working. They measured radiation, magnetic fields, and particles drifting between the stars. Voyager 1 was no longer just an explorer of planets. It was an explorer of the edge of the sun's influence. There is something deeply human about this endurance. The spacecraft was built for 5 years, maybe a little more. Instead, it has lasted decades. It has crossed boundaries no one thought possible, and entered places no human has ever been. Voyager 1's story is not just about science. It is about survival, about persistence, and about the quiet determination to keep moving forward no matter how far the journey goes. For all its distance, Voyager 1 still carries a voice. Its signal takes more than 22 hours to reach us, but it arrives, faint and steady. Each transmission is proof that the journey has not ended, that somewhere, out in the dark, a small machine from Earth still sails, carrying our story farther than we can follow. The Golden Record. The sun is more than a ball of fire. It breathes. Every second, it pushes out a stream of particles, electrons, protons, fragments of atoms, rushing outward in all directions. This flow is called the solar wind. Though invisible, it carries the sun's magnetic field with it, filling the solar system like an unseen tide. This tide creates a vast bubble around the planets.
The solar wind is blowing a bubble around our solar system.
Inside the bubble, the sun rules. Its winds shape magnetic storms, bend the tails of comets, and protect Earth from much of the radiation beyond. But even the sun's reach has a limit. At some distant point, its breath weakens until the forces of the galaxy push back. That invisible frontier is called the heliopause. Beyond it lies interstellar space. For decades, no one knew how far away this frontier stretched. Some thought it might be near Jupiter. Others believed it was far past Pluto. Only a traveler leaving the solar system could ever know for sure. Voyager 1 became that traveler. It moved beyond Saturn and kept going, past a region where the solar wind began to falter. By the 1990s, the spacecraft detected strange clues, bursts of radio waves, and sudden changes in charged particles. Something was waiting ahead, but the true crossing would take years more. Finally, in August 2012, at over 120 times the distance from Earth to the Sun, Voyager 1 slipped into a new ocean. The flow of solar particles almost vanished. At the same time, cosmic rays from the wider galaxy surged stronger than ever before. It was a quiet change, but a profound one. The spacecraft had stepped beyond the sun's breath. There was no sharp border, no visible line in space. Yet at that moment, humanity left its star's cradle for the first time. Voyager 1 had become our witness in the galaxy, sailing into the deep waters where the sun's light is only a memory. The edge of the sun's breath. Leaving the sun's bubble did not bring silence. Instead, Voyager 1 began to hear something unexpected. Its instruments picked up faint radio waves, pulses from the dark that no human ear could ever detect. These signals came at low frequencies, between 2 and 3 kilohertz. To us, they would be nothing but silence. But to scientists, they were evidence of hidden forces shaping the boundary between the sun and the galaxy. The discovery raised more questions than answers. The story behind the signals was tied to the sun itself. When a solar flare erupts, it throws a huge cloud of plasma into space. This cloud can take more than a year to reach the edge of the heliosphere. When it finally slams into the heliopause, it stirs the thin plasma outside, making electrons vibrate. Those vibrations release radio waves, which Voyager 1 quietly records. For researchers, these waves became a kind of map. They revealed that the space beyond the sun is not empty. Instead, it is thicker and more active than anyone once believed. What seemed like a void was alive with motion, shaped by collisions of energy that had traveled across unimaginable distances. Still, puzzles remained. One mystery was the direction of the magnetic field. Many expected it to flip when Voyager crossed the heliopause, pointing away from the Sun, but it did not. Instead, it continued in nearly the same direction. This strange coincidence left experts uneasy. Were we misunderstanding the very structure of the heliosphere? Or was something else at play? Something we had never imagined? Each signal Voyager sent back was fragile. Traveling more than 14 billion miles, the transmissions took nearly a full day to reach Earth. By the time they arrived, they were weaker than a whisper against the background noise of the universe, yet inside those faint signals was proof of a dynamic, restless frontier, a place where the sun's power fades and the galaxy begins. The radio waves were natural, but they carried an eerie weight. To some, they sounded less like data and more like a voice, distant, patient, and impossible to translate. The dark, it seemed, was not silent after all. Signals from the dark. Crossing into interstellar space did not mean silence. Soon after, Voyager 1 began to pick up strange signals. Radio waves too faint for human ears, yet clear on its instruments. They came in bursts, often linked to violent storms on the Sun. When a solar flare explodes, it hurls plasma into space. This material travels outward for months, even years, until it collides with the edge of the heliosphere. There, it shakes the thin plasma beyond the Sun's reach, causing electrons to vibrate and release radio waves. Voyager 1, drifting nearby, became a listener to these echoes. The signals were unlike anything detected inside the solar system. They hummed at frequencies between 2 and 3 kilohertz, far below what humans can hear. To scientists, they were proof that the spacecraft had entered a region far denser than the empty void once imagined. Interstellar space was not silent after all. Still, questions grew. Why did the magnetic field on the other side of the boundary look so similar to the Sun's? Why had some readings contradicted expectations? Some researchers began to wonder if Voyager was sensing something beyond the simple meeting of solar wind and galactic plasma. Each transmission traveled for more than 22 hours before reaching Earth. By then, the signals were as faint as a whisper against cosmic noise. Yet within them lay evidence of a hidden borderland, where the Sun's breath meets the greater galaxy. What Voyager was hearing could be explained by physics, but to others, it sounded like a deeper mystery, something alive in the dark, speaking in vibrations no ear could understand.
Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you.
Voyager 2 confirms the passage. For years, some doubted Voyager 1's crossing. Its plasma detector had failed long before, leaving a gap in the most important data. Without it, scientists relied on indirect clues, cosmic rays, radio hums, and changes in charged particles. Many accepted this as enough, but others wanted firmer proof. The answer arrived in 2018, when Voyager 2 followed its twin toward the same boundary. Unlike Voyager 1, its plasma instrument was still alive. When the spacecraft reached the edge, it recorded what Voyager 1 could not: a sharp rise in particle density. Interstellar space was thicker, filled with more plasma than the regions inside the Sun's shield. The readings were clear. Temperatures soared tens of thousands of degrees higher than expected, likely caused by compression at the boundary itself. The solar wind weakened, while cosmic rays from deep space grew stronger, just as Voyager 1 had observed. Most striking of all, the magnetic field once again refused to shift direction, repeating the earlier puzzle. This time, however, there was no doubt. Voyager 2 had stepped outside, confirming that Voyager 1 truly had left the heliosphere years before. The two spacecraft, now moving in different directions, gave scientists their first sense of how the solar bubble bends and stretches. The crossing ended the debate. Humanity had not one but two messengers sailing beyond the Sun's reach. Together, they became living proof that our star has a boundary, and beyond it lies a vast, unseen ocean, the hum of the void. Even after Voyager 2 confirmed the crossing, surprises did not end. In 2021, scientists noticed something unusual in Voyager 1's steady stream of data. Beneath the bursts caused by solar storms, there was another sound, one that never stopped. It was faint, a constant vibration in the plasma around the spacecraft. Not loud, not sharp, just a soft background tone, like a single note held forever. Scientists began calling it the hum of interstellar space. This hum was different from the storm-driven waves that Voyager had heard before. It was steady, rising slowly and gently over time. It suggested that interstellar plasma is not calm and empty, but restless, stirred by forces we barely understand. The sound revealed that space between the stars is alive with movement. Even in regions thought of as near vacuum, the gas is dense enough to sing, if one has the tools to listen. Voyager became that ear, catching vibrations no other probe had ever detected. For scientists, the discovery was invaluable. By studying the hum, they could measure density changes and watch how the plasma shifts over the years. For others, the meaning was more poetic. The universe was not silent. It breathed in whispers, carrying a constant song too low for human senses. The hum continues today, more than 14 billion miles from home. Each transmission takes nearly a day to reach Earth, carrying the faint pulse of the void. It reminds us that emptiness is never truly empty. Somewhere in that endless darkness, there is always a voice. Malfunctions and the unknown force. As Voyager 1 drifted deeper, its long journey began to show signs of strain. In 2022, engineers noticed something odd. The spacecraft's attitude control system, the part that keeps its antenna locked on Earth, was sending back corrupted data. Numbers that once made sense suddenly became jumbled, as if the probe no longer knew where it was. At first, it seemed like a failure inside a computer, but the commands were not coming from the right place. Somehow, the system had started using an onboard computer that had been shut down decades earlier. No one could explain why. The spacecraft had chosen to route its signals through a dead channel, and yet it kept functioning. NASA engineers worked carefully, sending instructions across billions of miles, waiting nearly 2 days for each reply. Eventually, they guided Voyager back to its normal system. The problem eased, but the question lingered. Why had it happened at all? Space is not gentle. Radiation, dust, and cosmic rays bombard the probe endlessly. Still, the timing of the glitch unsettled some. Was it simple wear after 45 years? Or had something in interstellar space touched the craft in ways we do not yet understand? Voyager 1 returned to stability, but the episode left a shadow of unease. It had reminded us of the spacecraft's fragility, and also of the unknown forces waiting beyond the sun's reach. Perhaps the malfunction was nothing more than aging circuits. Or perhaps it was the faint brush of a realm where our science still struggles to see clearly. Out there, even a machine can seem lost, whispering strange signals back to a world that can only wonder. Fragility against infinity. Every year, Voyager grows weaker. Its power comes from a small nuclear source, a block of decaying plutonium that gives off heat. That heat is turned into electricity, but less and less is produced as time goes on. To keep the spacecraft alive, engineers have shut down one system after another. Cameras, recorders, and even heaters have been switched off. In theory, some instruments should not work without warmth. Their designs called for safe limits far higher than the freezing dark of interstellar space. Yet a few of them continue to send data, even though their heaters have been cold for years. It is as if the machines refuse to die, clinging to life in a place that should destroy them. Voyagers 1 and 2 were never built to last this long. They carry technology older than most people alive today. Their memory is smaller than a modern calculator. Their data rate is slower than the weakest internet signal. Still, they endure. This survival feels both hopeful and haunting. The probes are fragile, yet they keep working against all odds. Each extra year is a gift, a moment borrowed from time itself. But it also reminds us that nothing lasts forever. The day will come when even the most stubborn instrument falls silent. Until then, the Voyagers continue to drift, fragile against infinity, their signals thin but steady, reminding us that endurance is sometimes the greatest mystery of all. The future of the Voyagers. The Voyagers cannot last forever. Their power source fades with each passing year, and soon even the most essential systems will go dark. Engineers predict that by the mid-2030-50s, maybe sooner, there will not be enough energy to keep the instruments alive. One by one, the voices will stop. When the last signal comes, it will mark the end of humanity's longest experiment in endurance. No one will be at the edge of the solar system to see the lights blink out. Only a final transmission, crossing the void for 22 hours, will tell us the journey is over. But the spacecraft themselves will not vanish. They will continue to travel, silent and unpowered, long after Earth has forgotten them. In 50,000 years, Voyager 1 will pass near another star. In millions of years, it may still drift through the galaxy, carrying its golden record like a sealed message in a cosmic sea. For scientists, the data already gathered is priceless. For dreamers, the future of the probes is something deeper, a reminder that we dared to send a fragile machine beyond the reach of the sun. Whether or not anyone ever finds them does not matter. What matters is that they exist, still moving, still carrying our memory into places we cannot yet follow. The Voyagers will outlive their creators, their nations, and perhaps even our world. Voyager 1 still drifts, silent except for its faint whisper across the stars. It is more than a machine. It is a trace of who we are, a reminder that even fragile things can cross impossible distances. Someday, its voice will fade, but its path will remain, carrying a golden record through the dark. Perhaps no one will ever find it. Perhaps it was never meant to be found. Yet in sending it, we proved something simple and profound, that humanity longed to reach beyond itself, and in doing so, left a part of its soul among the stars.